Welcome everyone to my session on asynchronous enterprise integration patterns. I know you had a choice between coming here for this session and going for will.i.am session, but you made it here, so thank you very much. So before I start, I want to get a sense of my audience. Take a look at the slide, and if you identify with this slide, raise your hands. If you use this in your personal or professional lives, raise your hands. Okay, I see a few hands. Well, the good news is, if you raise your hand, you have the concepts of this talk down to a pat. You can relax, enjoy the session. For those of you who had the hands down, you're going to learn a new life skill. I'm going to show you how to use it in your professional life, specifically in development. However, using it in your personal life, I have no guarantees. You have to use your best judgment for that. Now I know you guys. Let me quickly introduce myself. My name is Joe Dominic. I work as a senior architect at GE Capital. I've been at Capital for around 3 years. Our Salesforce instance at Capital has been around for 6 years. So in terms of clout and seniority, Salesforce far outranks me at GE. Hence, me standing here talking about Salesforce rather than the other way around. Before GE, I worked at a bunch of companies, mostly software development companies and big financial institutions. My background before Salesforce was primarily Java development. Before that, it was C, C++. I could go on and on, but I want to save you the grief, and I'll get started with the topic at hand, which is asynchronous processing. I'm sure 99% of you know what asynchronous processing is, but for that 1%, let me redefine it or define it by saying that asynchronous processing is when you take a task or a process and send it to the background for processing, and that process does not require any user interaction. So do all processes or tasks lend itself to asynchronous processing? Probably not. But there are a few reasons why you should consider asynchronous processing. One is better user experience. So if your user does not have to be really involved with the processing of the task, you should probably consider asynchronous processing. Think about emails and the way it works. So if you had to compose an email and if you hit the send button, if you actually had to wait for the email to reach the recipient before you could do anything else, I don't think email would have been so popular as it is today, or was till today. Another reason to consider asynchronous processing is, when you do asynchronous processing, what you're basically telling the system to do is, hey, system, take this process and execute it when your resources are available. So you're giving the flexibility to the system to do the processing rather than forcing the system to do it then and there. So the system uses its intelligence and is able to schedule the processing depending on resource availability. Now, when you do that, it lends itself to higher scalability within the system, more stability for the system, and the system in turn rewards you. And the way Salesforce or Force.com rewards you is with higher governor limits. So that's Force.com's way of saying, hey, thank you for letting me do this process asynchronously. Here's higher governor limits. So since we are talking about Force.com, let's talk about how would you do asynchronous processing on Force.com platform. So if you're writing Apex code, you would annotate your method with the future annotation. If you want to do bulk processing, you would use batch Apex. Now in Winter 15, there is a new feature called the queuable interface, which is very similar to the way the future annotation works. So apparently, I do believe a lot in code refactoring and not in PowerPoint refactoring. I haven't put that in my PowerPoint, just lazy. So the initial methods are explicit invocations to make it asynchronous. Now, if you have used bulk API, you know those requests get chopped by Salesforce and gets processed asynchronously. if you're running scheduled reports, that uses asynchronous processing. So Salesforce also has other processes or other things which it does asynchronously, but you can probably look it up and you get the idea of what asynchronous processing does. Now, what I would like to do is walk you through 2 use cases, which actually were problems we faced at GE, and how we used asynchronous processing to actually get over those problems. And the way I'm going to do it is, first I'll define the problem, I'll walk you through the solution, and we look at the final outcomes. So this is a very high-level view of a typical system architecture, or the way systems are laid out in an enterprise. Obviously, this is a highly simplified view of the system architecture. If systems were actually so simple, a lot of us here wouldn't have our fancy titles and jobs. Nonetheless, so if you follow the diagram from right to left, on the right, you have the typical applications which get built and exist within your corporate network, behind your corporate firewall. Now, with the advent of cloud computing and its associated promises of abstracting complexities away from the developer and letting you build applications a lot sooner, a lot faster, a lot of companies now migrate their applications to the cloud. Now, when you do that, there comes a requirement for your traditional applications or applications which sit inside a corporate firewall to talk to applications on the cloud. A very popular way to do it is using web services for a variety of reasons. It uses standardized technologies, XML, SOAP, JSON, SOAP, REST. Pretty easy to do it. And Force.com itself makes it very easy for you to build web services, right? You can take a WSDL, generate an Apex class, and you have a web service ready. Or you can go the other way around. So we at GE use web services for all our interaction with our internal systems. And we have been building web services for a long time. But over time, what has happened was these web services were talking to transactions which took a long time to run. And when these long-running transactions caused several problems. One, it had a tendency to hit governor limits. Another thing was, because these transactions were running simultaneously, there were resource contentions, there were DB locks happening. Then a lot of requests were getting timed out because the system wasn't able to scale itself. And then when your transactions start failing on the Salesforce end, there's a data mismatch between your sending system and your receiving system. And now you have to go through this entire effort of getting your data in sync. And we didn't want to do that, or we did that for a long time, and we decided to come up with a solution for fixing this issue. So we built out a framework. I'll walk you through the framework, and the way I'll do it is I'll talk about the building blocks, and then I'll put the entire picture together. So the fundamental thing that we thought about doing was, whenever a web service request comes in, we capture everything related to the web service request, store it in a data structure within Salesforce so that you can process it later or at that point itself. To do that, what we did was, first we created an object called queue. It's not the traditional FIFO queue, but just a plain old Salesforce object. You can see my Java background coming to work there. So the queue stores the web service metadata, and the object structure in which the web service payload comes in, that is serialized into a string. And then we store the serialized string into the queue. And when I say serialized, I mean you can save it as XML or JSON or whatever is your preferred format. Doing this gave us the capability of having the request on demand. So we could either take the request, process it then and there, or process it as a future task. Now, there was one problem with this initial queue design. The thing was, the payload size could vary dramatically. And luckily, we found out before going to production. So what we did was we created another data structure called the data store. Again, it's a POSO. I just like saying it. So the way the data store works is if you send it, it's got a handler class in front of it. You send it a string, it chunks it into, it splits the string into chunks of 32 kilobytes, adds an order index to it, and stores the order index, the 32 kilobyte chunk, and the ID to the queue in the data store. So the store method of the utility class would do the chunking and store it in the data store. The retrieve would obviously concatenate everything and give you back the full string. We added some custom indexes to the queue and the order index so that reads would be faster. And the size of the data store would increase dramatically depending on the amount of web service requests that were being stored. So this was the data storage part of the web service. Now since we were able to store the data, we had to actually process the data. So for that, what we did was we built out this transaction framework. So the classes that you see in green are the framework classes, and the classes that you see in blue are the business classes. So again, the framework classes I've taken out all the, there are a lot more classes to the framework, but it's probably not relevant for you to understand this framework. So what I've done, the main class on the framework side is the abstract web service handler. So this handler typically takes care of interacting with the data store and the queue, saving all the transactions to the data store and the queue. It takes care of things like logging, writing the metadata. All those things are written in the abstract web service handler and its associated classes. Now, if a business developer wants to build a new web service, he needs to do just two things. The first thing that he needs to do is build an interface, or it's an actual class, but it's a web service interface. He would typically generate that out of your WSDL. And then he would have a corresponding business handler where he would execute the business logic for that particular web service operation. Now, the business handler extends the abstract web service handler, which means it gets all the functionality of the framework. And by this, so if you think about it, the business developer does not really care about the data store and the queue and all those things, since the abstract web service handler pretty much takes care of all those things. So let's take a look at the entire framework and do an end-to-end walkthrough and see what we've built out. So on the top left, you have the web service request coming into your web service interface. The web service interface passes that request to the business handler. The business handler, since it extends the framework classes, it just takes the request, stores it in the data store in the queue, and then it's able to give it back to the business handler whenever it's required. So this is where the asynchronous processing happens. So when a business developer writes the business handler, he can pretty much decide whether that process needs to be synchronous or an asynchronous process. So if it's an asynchronous process, our framework guarantees that that particular transaction would be available for that process when it's being processed asynchronously. So this was the framework that we built out. There were pretty good outcomes of this. First of all, it was scalable because now all the long-running transactions were now moved to asynchronous processing, which meant the system wasn't clocked by these long-running transactions, which meant response times decreased dramatically. We were able to do on-demand reprocessing of data, of web service requests. So even if your transactions fail, we were able to reprocess it, and we were able to get the system back in sync. Then we were capturing a lot of metadata about our transactions, so we could do trending and analysis and figure out if the performance of our web services were declining or not. So this was the first framework that we built out, leveraging a lot of asynchronous processing. So next, let me talk to you about the next framework that we built out. Now, this was not the framework, but it actually symbolizes something. So as we roll out our web service framework, and over time, we started, since we had all this metadata for doing trending and analysis, we found that there were certain transactions which were taking much longer than expected. Now, a reasonable answer to that would be like, yeah, you are adding functionality, so obviously your transactions are going to take longer than expected. But there were some anomalies in a few transactions. Then our users started complaining that a few of the actions which took probably a second or two previously were taking 5-6 seconds. And that was kind of unacceptable to the users. So we started digging into what the problem was, and we figured that our instance of Salesforce had become obese, or we were suffering from uncontrolled data growth. So the first thing that we did was obviously use data manipulation tools like Apex Data Loader and other third-party tools to try and delete data. But that had a few problems. One big problem was it was a very manual-intensive work. Another thing was the rules that we had to delete data or choose records for deletion were pretty complex, and most of these ETL tools couldn't handle that. So that gave us an opportunity to go back to the drawing board, put on our engineer's hat, and build a framework, and we're pretty excited to do that. So we started talking with our business stakeholders to come up with the requirements for this new framework. And most of the requirements were fairly straightforward or expected. One of the few weird requirements were like not only did we have different rules for each Salesforce object, but even within objects, rules varied depending on record types or depending on which business those records belong to. So that was something that we had to take care of in our framework. Then our auditors got wind of the fact that we were trying to delete data from Salesforce, so they were not too happy with it, so they wanted us to take a seat on the table. So they wanted us to review each and every record before we actually deleted it, and if they felt that any record should not be deleted, we had to make sure that that wasn't deleted. From the technical side, we wanted to make sure that everything was handled within Salesforce itself. We did not want to have to depend on other teams for running our frameworks. We needed to make sure that there was no impact on our day-to-day operations. That was a big ask from us as well as from the business folks. And when you delete data, if you have lookup relationship, what happens is you tend to leave orphan records. And we needed to make sure that we were not leaving orphan records when we were deleting data. So again, we went about building out a framework. I'll walk you through the building blocks, and then I'll put the entire framework together. So the first thing about our framework is the policy. A policy is nothing but the rules which define how you choose or which records you choose for deletion. So when we started building out the framework, we were able to segregate our policies into two types. One was the SOCL policy. SOCL policy is when the policies can be captured as SOCL statements. And the other thing was Apex policies. So those were a lot more complex rules, and they had to actually be defined as Apex classes themselves. So once we had the policies in place, we needed a place to store the policies. So we came up with an object called policy store. Again, it's a POSO. You can think of it as a central repository of all our policies. And what we did was the policy store stores the policies, and does some basic validation of the policy. So if it's a SOCL policy, it's going to validate whether the SOCL statement that is entered along with the policy is right or not. If it's an Apex policy, it'll validate whether it implements the right interface. And then it stores a bunch of metadata associated with the policy. So let's take a look at a typical policy store record. On the left-hand side, the entity name is probably the most important aspect to it. It defines on which entity you're creating the policy. On the right-hand side, you'll see information like whether it's a SOCL policy or a class policy. You'll have, since this is a SOCL policy, you have a SOCL statement. Obviously, this is not a typical policy. This is just a fake policy that I created. Then there's a bunch of scheduling information. We needed to make sure things run off business hours, so we had to build in a scheduler for this. Now, another thing to notice is something called the purge within. This is you can think of this as the review period that the auditors get to review these records before they are actually deleted. And everything else seems fairly straightforward. So let me talk you to, now that we have the policies in place, we divided our framework into two parts. The first part we call as the mark cycle, or the mark phase. So essentially what happens in the mark phase is you go through the policies or the rules and choose the records which meet the criteria and mark those records as ready for deletion. We don't actually delete anything, we just mark it for deletion. And the way we do it is we first have something called as a policy runner, which is a scheduled job which runs nightly. And what that does is it goes to our policy store, inspects all the policies, and if there are any policies that need to be run on that particular day, it creates something called a policy job for that. Now, the policy job is the workhorse of this entire framework. So it obviously, since we're talking about asynchronous processing here, it executes under the future context. And a big reason for that, obviously, is because we needed to leverage the higher governor limits of Salesforce. So the policy job gets the context under which it needs to execute, which means it gets the entity name. And then it goes, looks at the policy store with that entity name, figures out all the policies for that entity. Then it does the job of going and matching those policies against the records. And once it gets the records, it goes and marks it with a purge date or the retention date. The purge date is nothing but today's date plus the amount of time the reviewers need to actually review the record. So at the end of this phase of our framework, what you would have is records and objects marked with a purge date if they met any of the rules. Then we come to the second phase of our framework, which is the sweep phase. This phase works very similar to the mark phase. And in this phase, this is the phase where the actual deletion happens. So the way this works is, again, there's a purge service, which is a nightly job. It reads, again, it goes to the policy store. It reads all the objects that potentially could have records for deletion. And then for each record, each distinct entity, it creates a purge job. Now, the purge job, again, is the workhorse of this phase of the life cycle. So the purge job check gets the context under which it needs to execute. It goes and checks if there are records whose retention date is past today's date, and if there's no holds in them. If any of those conditions are met, we actually go and delete the records from Salesforce. Under certain conditions, we take a snapshot of the record that was deleted and we write it to an audit table. The audit table gets backed up externally, and it gets truncated on a nightly basis. So now, to put everything in one big picture, this is how the entire architecture would look like. At the heart of our framework are the policies, the policy store. That's where you define all the rules for deletion. On the left side, you have the mark phase, wherein the policy runner looks at the policy store and figures out which policies need to run. And based on those policies, you choose records for deletion. And it just marks the records for deletion. On the sweep side, what you have is the actual deletion happening. The purge service looks again at the policy store. It looks at all the records which have a retention date which is greater than today or less than today, and deletes those records from Salesforce. So once we rolled this out, it actually was a considerable success for us. From the technical side or from the IT perspective, we were happy because there was no manual intervention required except when you needed to change policies or write new policies. We use a lot of dynamic Apex for building out the framework. Everything is a dynamic Apex in that framework. So that was a good learning experience for all of us. We were able to make sure that there were no orphans left as part of our deletion. The business users were happy because they got to write rules, and each of them got to have whatever rules they wanted. So they were pretty happy. Our auditors were super happy because now they had the say of whether they wanted a record to be deleted or not, and they got a seat on the table. So, in conclusion, just to review what we covered so far, we covered one use case wherein we were covering a framework to handle web service requests. The other framework was to control data growth. And my aim for this talk was not to make you experts in asynchronous processing, but to just convey the message that asynchronous processing is your friend. So you need to use it. If you're not already using it, please use it. Take a second look at it. It's a really powerful feature in Salesforce. Make sure that you're using it and have fun. So that was my presentation. Thank you very much for coming. If you have any questions, I'm open. I'll be around here if you want and can come up. Sure.
What volume do you have to deal with, especially for asynchronous processing?
The volume of data? So there was we had some objects, especially the log objects, where we had around 1 million records being created on a daily basis. So that was a huge amount of data, and that was causing a lot of grief for us.
Yeah, for asynchronous data updates back into your to the ground systems, did you consider any outbound messaging capability?
Sorry, I didn't get
Outbound messaging capability.
For the web service request?
Yeah.
No, this is strictly for inbound. For outbound, we have a different pattern, different paradigm. What we built so far did not suit the outbound messaging, so this was strictly inbound.
Okay, thank you.
Question about how you differentiated between the SOQL-based policy and the dynamic Apex.
Okay.
How were you actually storing your SOQL query within your policy object, and the dynamic Apex, was that like the construction of a DML statement, or how is it? In which way was it dynamic, and then how did you store it within the policy?
So yeah, so since it's all dynamic Apex, so things like, so we capture the entity name, so you pretty much know, we construct the SOQL statement dynamically. So from the entity name, you get the object on which you're operating on. Then we have few fields like ID. We do a select ID, name, few standard fields on that object, and we append the SOQL statement at the end of it. And then we put some other standard statements, like if you have a purge state along with it already in it, you don't choose that record for deletion, things like that. So it's all dynamically constructed.
Thank you.
You're welcome.
I have a question related to data security.
I can't actually see you. Oh, there. Okay.
Have you encountered any issues related to the data visibility and security permissions for those records that you are processing in the first web services calls?
Yeah, so most of actually all of our transactions execute under the context of a generic integration ID.
Okay.
So we did not have, so there's nothing which comes, and there are no transactions which come in as a user's ID. It's all generic IDs. So we didn't have to deal with those kind of security issues.
Yeah, thank you.
Yeah, welcome.
Sorry, I have one more question.
Sure.
I've implemented something similar using a log to record the success of a asynchronous batch integration, and one of the issues that I came up with was if a individual execution fails, I was concerned that I wouldn't get successful writes to the log. So how are you logging, and how did you handle the fail case?
So the failure case, I would probably say there are two types of failures, right? One is if you're hitting governor limits, you're done. You can't do anything. You're toast. But the other scenario wherein it was a business failure or exceptions, we were able to handle the logging in the finally clause. So we were able to store the logs. But governor limits, if you're hitting, I don't think we could do anything with it. Okay. Thank you all for coming.